Welcome to my YouTube channel KK Concepts of Electrical Engineering. Today's topic: voltage control of three-phase inverters. From the subject: Power Electronics. Voltage control of three-phase inverters. A three-phase inverter may be considered as three single-phase inverters, and the output of each single-phase inverter is shifted by 120 degrees. The voltage control techniques which we discussed earlier, like single pulse width modulation (PWM), multiple uniform pulse width modulation (MPWM), sinusoidal pulse width modulation (SPWM), modified sinusoidal pulse width modulation (MSPWM), phase displacement control are applicable to three-phase inverters also. For more details, please check the I button. Example: generation of gating signals with sinusoidal pulse width modulation. There are three sinusoidal reference waves, each shifted by 120 degrees. A triangular carrier wave is compared with the reference signal corresponding to the phase to generate gating signals for phase. Output voltage is generated by eliminating the condition that two switching devices in the same arm cannot conduct at the same time. The sinusoidal pulse width modulation (SPWM) is the most commonly used, having the drawbacks like low fundamental output voltage. For improved performance, we look for advanced techniques. Advanced modulation techniques: trapezoidal modulation, staircase modulation, stepped modulation, harmonic injection modulation, delta modulation is also known as hysteresis modulation. For the sake of simplicity, we shall show the output voltage for half bridge inverter VA0, for full bridge inverter V0, which equals to VA0 minus VB0, where VB0 is the inverse of VA0. Trapezoidal modulation. The gating signals generated by comparing triangular carrier wave with modulating trapezoidal wave. Trapezoidal wave can be obtained from triangular wave by limiting the magnitude to plus or minus AR from the peak AR max. AR equal to sigma AR max, where sigma is called triangular factor because the waveform becomes a triangular wave when sigma equals to 1. The modulation index M equals to AR by AC. The angle of flat portion of trapezoidal wave is given by 2 phi. Fundamental output voltage increased up to 1.05 VS and contains lower order harmonics. Staircase modulation. Reference signal is staircase wave, which is not approximated to a sinusoidal. The level of stairs are calculated to eliminate specific harmonics. The modulated frequency ratio MF and number of steps are chosen to obtain desired quality of output voltage. For high fundamental output voltage and low distortion factor, the optimum number of pulses in one cycle is 15 for 2 levels, 21 for 3 levels, and 27 for 4 levels. Stepped modulation. Reference signal is a wave which is not approximated to sinusoidal, divided into specific intervals. So 15 degrees in our case, with each interval being controlled individually to control the magnitude of fundamental component and eliminate harmonics. Provides low distortion and high fundamental amplitude than normal PWM. Harmonic injection modulation. The modulated signal is generated by injecting third and ninth harmonics to the sine wave. Here you can see this. as shown in this figure. This results in flat tapped wave and reduces the amount of overt modulation. Modulated signal composition for this is VR equals to 1.15 sine omega t plus 0.27 sine 3 omega t minus 0.027 sine 9 omega t. The injection of third harmonic will not affect the quality of the output voltage, as three-phase inverter does not contain TRAPEZOIDal harmonics. It provides low distortion and high fundamental amplitude of the output voltage. If only third harmonic is injected, VR equals to 1.15 sine omega t plus 0.19 sine 3 omega t is the composition, and the modulated signal as shown here for A, B and C. The line-to-line voltage is sinusoidal PWM and amplitude of fundamental component is approximately 15% more than normal sinusoidal pulse width modulation. Since each arm is switched off for 1/3 period, the heating of switching devices is reduced. Delta modulation or hysteresis modulation. A triangular wave is allowed to oscillate within a defined window of delta V above and below the reference sine wave VR. The switching function, which is identical to the output voltage V0 generated from the vertices of the triangular wave VC, as shown in the figure, also known as hysteresis modulation. If the frequency of modulating wave changed, keeping the slope of the triangular wave constant, the number of pulses and pulse width of the modulated wave could change fundamental output voltage up to Vs and dependent on amplitude AR and frequency FR of reference voltage, can control the ratio of voltage to frequency, which is desirable feature in AC motor control. The summary of advanced modulation techniques. Now, the trapezoidal modulation provides fundamental output voltage increases up to 1.05 times of the Vs and contains lower order harmonics. The staircase modulation provides high quality fundamental output voltage up to 0.94 Vs. Stepped modulation provides low distortion and high fundamental amplitude than normal PWM control. The harmonic injection modulation provides low distortion and high fundamental amplitude of output voltage. Delta modulation or hysteresis modulation provides fundamental output voltage up to Vs and dependent on amplitude AR and frequency FR of the reference voltage, can control the ratio of voltage to frequency, which is desirable feature in AC motor control. Thank you for visiting my channel. Please like, share and subscribe.